Hello, you are welcome once again to Maths Clinic series. In this video, we are continuing the series of binary operation. And here we've gotten to some of the properties of binary operation. In our previous lesson, we looked at commutative property. Today, we are asking a very big question. What is associative property in binary operation? What is associative property in binary operation? In a very simple definition, a binary operation star on a set S is said to be associative if A operation B operation C is equals to the same A operation B operation C. Nothing has changed. Just that in doing operation, I can do the first two before the third one, or do the last two before the first one. When I do this and the left hand side is equals to the right hand side, then I will say the operation is associative. The operation is associative. In this case, the order in which the elements are combined does not matter. For example, if I have say a set of n, that is set of natural numbers, and the operation addition comes as A operation B operation C, or A plus B plus C, the same as A plus B plus C. If I do the A first and B before doing the C, or adding B and C before doing the A. For example, if I have 4 plus 7 plus 9, the same thing I've written here, 4 plus 7 plus 9. But then I can do 4 plus 7 first before adding the 9. Or I'll do 7 plus 9 before adding the 4. When I do this, you see that the 4 plus 7 will give me 11 plus the 9 here, or 7 plus 9 will give me 16 plus the 4 here. Each case, I'm going to get 20, 20. So since the left-hand side is equal to the right-hand side, my conclusion is that addition is associative under the set natural numbers. Right. Now, if I do the same thing for multiplication, okay, say I have 4 times 3 times 5, 4 times 3 times 5. I'll do 4 times 3, which will give me 12. And here I'll do 3 times 5, which will give me 15. And I can have 12 times 5 here and 15 times 4 here. 12 times 5 will give me 60. 15 times 4 also give me 60. Since the left-hand side is equal to the right-hand side, my conclusion is that the operation multiplication is associative. But look at it from here. If I do the same thing for, let's say I have 2 minus 3 minus 5. 2 minus 3 minus 5. The same thing I've written, but then I'm going to do the operation. So here I want to do this one first, and that will give me -1. Okay, then minus 5 here. And here I want to keep the 2 first and do this one rather first. And when I do that, here I have -2. Now on the left hand side, -1 minus 5 will give me -6. Here 2 minus -2 will give me 4. And since the left hand side is not equal to the right hand side, my conclusion is that the operation subtraction is not associative. Pause the video and try it for division and see whether it's going to be associative or not. I'm sure you did that and it is not associative as well. And so for the fundamental operations, addition and multiplication are associative, while division and subtractions are not associative. Right, so let's look at it in a more practical way. When we talk of associative, we are saying grouping doesn't matter. Let's say you are gathering fruit at Makola Market, okay, and you initially picked, let's say, 5 oranges, and then you add 3 apples before bringing in 2 bananas. Or the other way around, you have 3 apples picked first plus 2 bananas before adding the 5 oranges. In both cases, you get the same content in the basket. So order does not matter. And so that is associative property for you. Right. Now let's look at this in context of solving questions. Let's say I give you a question like this. Determine whether or not the operation star here is associative, given that s star y is equals to s plus y plus xy. What it means is that if you have 2 star 5, it means do 2 plus 5 plus 2 times 5 and then simplify. That's what it means. But if we are defining x and y to be set of real numbers, would this particular operation star be associative? Now let's see how it works. Now for us to say the star is associative, then if we say s operation y operation z should be the same as s operation y operation z, I could do the first two first or the last two first. If it is the first two, based on this two and the definition that we have here, we can say that s star y is s plus y plus xy. Then we bring our star z. Okay, is equal to, here we maintain our s. Okay, and then y star z, sorry, yeah, y operation z is the same as, based on the definition again, we have y plus z plus yz. I hope it makes sense. Good. Now we want to treat this as an entity, okay, operation z, because that also becomes one entity. So that is going to represent our x over here. That is our head x here. And we operate it with z. And then the right hand side too, we are going to treat the whole of this as one entity, operation x. So for the left hand side, this represents my x while this represents my y. And by definition, is going to be x plus y, okay, plus xy. That is it. Then I get it this way. It's equal to, now when I come to the right hand side, the x also represents x originally as it is, and the whole of this represents my y. And so it's going to be x plus that y plus x times y. Do you see that? Beautiful. So we get this one as such. Good. Now we want to simplify to see whether the left hand side will be equal to the right hand side, so we can conclude whether the operation star is associative. So I can simplify the left hand side a little bit. I have my s plus y plus xy plus z plus, I want to multiply this together, and that will give me that. Then on the right hand side here, I have my x plus the whole of this, okay, then plus multiplying this one through will give us that. So now can we compare? You can pause the video and look at it critically to compare the left hand side and the right hand side and see if they are the same. Of course, you can see that x is here, x is here, y is here, y is here, xy, xy, z alone. Here too we have z alone. We have xz here, we have xz here, we have yz, we have yz, and we have xyz, we have xyz. So if I put a number in place of xyz and I simplify the left hand side to be the same as the right hand side. So since the left hand side, okay, is equal to the right hand side, the conclusion is that operation star is commutative under this definition. I hope it makes sense. Let's take another example and see. You can pause the video and then try your hand on this as well. Okay. It's almost the same. The difference is that here we have minus 2 xy to see if having minus in there could cause the associative property not to work for this very definition. And so again, I'll walk you through that. You can take your time and then review the video again and then understand it well. And so by the definition, the operation dot here is defined as x operation y is equals to x plus y minus 2xy. And so again, I have x dot y dot z, the same thing on the left right hand side. But then I can do the first two first before the last one, or the last two before the first one. If I go through the same approach, this operation this by definition will give me x plus y minus 2xy. Then I bring my dot z is equal to, here too I keep this one, and then y operation z by definition will be y plus z minus 2yz. Now I'm going to treat this as one entity, operation z. Then I also treat x and this as one entity, operation x. Now I'm going to call the whole of this as my x, and then this becomes my y. And by definition, I'm going to get the whole of the x plus the z plus minus 2 times the whole of the x times the z. Right? If you are confused, you just pause the video and walk through it again and see. Then I'm going to have my x here plus the whole of this representing my y, okay, and then minus 2 times my x and then the y. You see that? Beautiful. Now I'm going to simplify the left hand side and that of the right hand side. When I do that simplification, I'm going to have the left hand side representing this, whilst the right hand side also representing that. So my question now for you is, check whether the left hand side is equal to the right hand side. What it means is that if I say let x be 2, let y be 4, and let maybe z be 3, and I put x in place of x, y in place of y, and z in place of z, and I simplify the left hand side and that of the right hand side, will I get the same thing? Of course, if you study this critically, you see that you are going to get the same thing. And for that matter, we'll say operation dot here is associative. Is associative. Good. Now, I want you to use this same idea to do this particular work, okay, and check whether operation star will be associative or not, having this definition here, right? I'm sure this has really been a blessing to you to understand what associative property is as far as binary operation is concerned. Thanks so much for watching.